Pittsburg.
Okay, yeah, I heard it was when somebody described the traffic.
Well, it doesn't take my advice.
I went to Derby line, and it was still bad. It's kind of on and off in 91, but it was extremely bad north and now.
That's why my advice for a whole year has been stay over Monday night.
I know.
On Tuesday.
Yeah, I did a U-turn to the median after 2 hours, 2 miles in 2 hours, and then did a long circuitous route to the Connecticut River Valley, cut over on New Hampshire 25 to Plymouth, and then campus. I still got back on midnight at 12:30, but it was traffic. It was, it was like 5,000,
Oh, yeah.
the college. It felt like it was like in northern New Hampshire, it was Las
Well,
Vegas. There was like tons of cars going through the town to drive.
It was 120,000.
Yeah, it was.
Lost County.
Yeah.
And that was by its tourism coming counted, or however they do it. 120,000 visitors to Lost County.
Yeah, I know a guy who works at the museum up in St. Johnsbury. He said it was super packed. And they got a minute and a half.
Yeah.
It was like it was crowded up in the streets of St. Johnsbury.
Yeah.
Derby line was like just a municipal park. It was still like 100 people. And right with that. I hope it's a little better than 2017. I had to go all like 4 miles.
Kentucky.
It's a little bit less of a drive this time.
Is this the room for Albert Einstein?
Yes, it is.
Okay.
Come on in. Sit wherever you like. Closer to the front, the better. I knew you were coming.
Jackson is getting more. Is this it like, yeah, I guess it is. So good.
couple more at the desk. Whenever you say go, I'll go. All is well. You know your children? You know that. Where do you come from?
Waterville Valley,
Oh, I love Waterville Valley. Yeah.
very peaceful up there.
Yes. I used to, you know, I'm sure you do, the George Cottage.
No, actually, I don't.
Oh my gosh, you need to tell me. So it's on Noon Peak Road,
Okay.
and we do, in the Hampshire Astronomical Society, there's a Skywatch program once a month there.
Oh, that's neat to know.
Yeah, so check it out at the, I don't know,
I will.
the local place where you check things out.
Thanks for letting me know.
And that's where Hans Ray wrote Curious George from, was that cottage. That's why it's called Curious George. Oh, where is it? That's a summer. Where are you folks from? Oh, good. It's a good place to be. Where are you folks from? Lincoln. Little south. Oh, thanks for carrying. You're the first one. Billington.
We've set precedent already.
Well, good evening, ladies and gentlemen. How's everybody tonight? Good, good. How did you sleep last night? Horizontal? My name's Dave. I'm Dave McDonald, and I'm a senior educator here at the McAuliffe-Shepard Discovery Center. I work part-time on weekends, and I am full-time teacher at Belmont High School in Belmont, New Hampshire. I teach STEM stuff, and I was education director here for 10 years, from 2002 to 2012. And it was in 2005, which was going to be and was the 100th anniversary of Einstein and his greatest hit, so to speak. And so I was putting together a Superstella Friday evening, like we're having here tonight, about Einstein. And we actually had a series of things for months about the 100th anniversary of his stuff. And so I was with our producer at the time. We were looking at what are called Challenger Learning Centers, like after the Space Shuttle Challenger that unfortunately exploded, Krista McAuliffe and the rest of the crew and such. And so on our journey out to Iowa and Indiana, checking out these places, there was a guy named Marty Schwartz. And Marty Schwartz was like the salesperson for these Challenger Learning Centers, which are very expensive. They're like $1.5 million to have one, and such. So I'm working on my first ever Einstein presentation. This is again back in 2005. And so in the car with Marty, I just wasn't expecting anything. I'm sitting in the back seat, and so I said, Marty, do you by any chance know anything about Einstein? And he said, funny you should ask. Well, that got my attention. And he says, well, as a matter of fact, my uncle was Einstein's accountant. Who would have guessed? So there's a photograph coming up, not in this particular piece, but in the third piece that I'm going to show you tonight. It's literally from his family album. And nobody else, it's not been in National Geographic or any place else. It was just from this family album, scanned to me for my use. And he said, just don't share it with anybody, just use it yourself. Deal. So you'll get to see that, but no pictures. So anyway, Did anybody get to go to North Coos County or elsewhere in the country to see totality? Who got to go? Good. Awesome. Who did not get to go? Okay. Who doesn't feel like raising your hand tonight? Okay, yeah, there's always one. So let me share with you some photos of the eclipse, and then I'm going to share with you a video about the eclipse experience. I went to Pittsburgh, and I brought, and I was going to wear, it's just a little warm up here to be speaking, but I do have one of 10 different sweatshirts that I bought up in Pittsburgh. And so this one is, let me get over here, so the folks at home. Total eclipse of the sun. And one thing I like about it are many things. Pittsburgh, New Hampshire, and Eclipse 2024. The thing I like about it, the show times, the concert schedule, right? Just like, you know, a groupie concert sweatshirt, and then highlighted is Pittsburgh. So all the various cities and states that had totality going through it, there's Pittsburgh, and then the next one would be Caribou, Maine. So if you don't mind, I'm just not going to wear that tonight. Let's move on with a few photos here then. This is where I was. This is in Pittsburgh, about 5 miles north of town. And that looks not very descriptive. That looks like a pile of junk, but actually that is a spread that will be spread out to watch the waves when the eclipse is coming. There are they're called shadow bands that happen. So that's what that's for. That's not like trash. And then these are the people who were there in this house, 3 houses like that. And let's see, I can never find myself. Here I am, over here wearing yet another eclipse shirt. I don't know if you can see, but the raccoon has eclipse glasses on and such. And then here's a picture with everybody with their eclipse glasses on before the eclipse starts. So, this is towards the beginning. We're getting our first bite out of the sun here. And you can see there's a couple of sunspots there. All righty. And let me just see what you think. If this is a good idea or not. So, lights are going off, so don't be scared. Is that good, or do you rather the lights on? A, B. And you're the eye doctors. A. Okay. So, the shadow of the moon is, and this is the only time we get to actually see a new moon, because we're really looking at a new moon phase. And we're approaching this group of sunspots. And now we have covered that group of sunspots. I'm zoomed in a little more, and we've got a couple more sunspots there. So we're roughly a little beyond halfway. And then, you know, we get to totality, and this is a handheld camera, 30-year-old handheld camera. And so that's Venus, that little, I was holding it by hand, that's Venus. And that's maybe a little better. You can see I think you can see the black dot in the center, which is the shadow of the moon. And then that's the corona all around it. So you can see that's Venus, and then you have the corona with the dot of the moon there. And, ready? Isn't that cool? So the moon is covering the sun, obviously, and all the bright light that you see around it is the corona. We have a star here. That's going to come into play a little later in my discussion. I think that's Regulus. And then a student of mine, also in Pittsburgh, took this picture. And I kind of like this because it has, like, you know, a foreground here with trees, and you can still see the black dot of the moon in front of the sun. And then it's time for the eclipse to be over. So the moon is making its way past the sun. And now this group of sunspots is reappearing. And then we're close to the end there. And then a friend of mine, this is done by Ed Ting. Ed Ting is a notable telescope enthusiast. He reviews telescopes for Astronomy Magazine and Sky and Telescope Magazine. And he put this collage together from Colchester Point in Burlington, Vermont. And it shows the progression of the eclipse, as you can see. And then we have the corona showing in the middle. There was some nice flare activity around the sun. And so some shots you'll see have a little pinkishness there. And that's a solar flare that is becoming visible because of the eclipse. And then the moon makes its way away. So I thought that was well done, as Ed Ting always does things. And then another friend of mine, Rick Feinberg, who was a chief editor of Sky and Telescope magazine, went out on a cruise with Insight Cruises, and he put this together, which is more pictures, but a couple other effects here that we call the diamond ring, both before and after. And you can also see nicely these pink items around, which are the solar flares that are happening. And this is a composite. He is an avid astrophotographer, and so he overlaid pictures that he took of these prominences and these solar flares to put them in the correct position during totality, which you could see, depending upon what you had for binoculars or telescope or filters, you could see the color or maybe not, depending what you were using. So, cool? Yes, that's the right answer. Okay, so now I'm going to switch to, I'm just going to sit down because I need to work with my computer for a second here. And I'm going to show you a video of the experience. So I'm going to close this up, and funny things happen, but eventually the right thing will show up. At least it did last time. So this is up in Pittsburgh. This is at the Pittsburgh School. There's one K through 12 school. You'll find out more about that in a moment. Hi, this is Dave McDonald with the Sky this month, and we just launched a weather balloon. And with me is Jacob Garside with the new Plymouth State University and NASA balloon launching, as you can see, Plymouth State Balloon Team Nationwide Eclipse Ballooning Project. Jacob, tell us a little bit about what this project is all about.
So Montana State University got a grant from the NASA Science Activation Program to launch balloons during these two eclipses that are so close to each other. We had the annular eclipse back in October 14th of 2023. Now we've got this one in April 8th. This is April 7th. We're excited. We're just getting everything ready. NASA specifically wants to learn more about stratospheric gravity waves, but here at Plymouth State we're learning about the boundary layer, how that's affected during the eclipse. So that's the first 2 kilometers of the atmosphere here.
And Jacob, we just saw the launch of the first balloon, and how many balloons will you be launching from the site here in Pittsburgh?
Well, we're going to launch 59 more balloons, so 60 total. So we have 30 hours here. We're going to be 24 hours before the eclipse and 6 hours afterwards. And then because we have two teams here, we're actually launching a balloon every half an hour, which we're pretty excited about.
That's really awesome. And at the moment, the weather's looking great for the rest of today and tomorrow.
Yeah, we're going to hope. I'm praying. I've never seen a total solar eclipse, and I'd really like to see one. The annular one just doesn't quite compare. So I'm really excited.
And we're all looking forward to that. And of course, the great solar eclipse here in Pittsburgh, New Hampshire. Jacob, thanks so much for joining us.
Of course, Dave, anytime.
So this is just background audio. I'm not narrating this. 3 different views, 3 different telescopes. Just about to disappear. So you can actually see the movement of the moon across the face of the sun. And this is from a different telescope. And again, you can see that's real time happening. And then I pull the filter off and it gets very bright real quick. But you can see down the bottom part, the pink that I was talking about. And watch, the diamond ring appears, because this is real time. And then at a certain point, it just gets too bright.
99.9.
This is a video camera.
Glasses off. See the diamond ring? There's a corona. Little bit of Bailey's beads. Look at 11 o'clock. That's the corona, folks. It's 6, 7 o'clock, the red. Binoculars, so hang on. Take a look, take a look. How we doing on time, Dave?
I don't know.
Okay.
I got 331. There it goes.
Glasses on.
There it goes.
Different, darker.
Different camera.
99%. 99.9.
Same people saying the same
Glasses
things.
off. You have Jupiter upper left. And I don't see Rigel yet. That is a breakthrough. Couple more dim stars around.
There's Venus, lower right.
Venus.
Jupiter is upper left. Not in this view.
There's another one. There's 2.
They don't know what's going on.
It's 6, 7 o'clock, the red. You need binoculars. Take a look. How we doing on time, Dave?
I don't know.
Okay.
I got 331. There it goes. There it goes. Tiny little bit. 3, 2, 1, a half, a quarter. I think I'm calling it. I I'm here with Ricky Eames, and I understand this is your first eclipse, your first total.
Yeah, that would be correct. This is my very first one.
And tell us what was it like? What was the experience like?
Pretty eerie. It got dark and cold. It felt like I was on a completely different planet. It was truly incredible. Yeah, definitely enjoyed it.
And hopefully you'll be around for May 1st, 2079.
Yeah, the next one in New Hampshire, I'll be 87 years old, so I'll definitely be here. Yeah.
Very optimistic young man. Way to go. Thanks for being with us today, Ricky.
Thank you so much.
It was a good time, and I'm Dave McDonald for the Sky This Month. I'm Dave McDonald with the Sky This Month, and we're doing our interview here with Dawn Eames. And Dawn, tell us, what was this experience like?
It was truly magical. I don't really have any other words except for magical, breathtaking, it's spiritual.
Yeah.
And we hope that you enjoyed it with the video we were able to share with you, and hope you enjoyed it as much as Dawn did. I'm here with Gary Gladstone, and we just finished observing the total solar eclipse here in Pittsburg, New Hampshire. Gary, tell us, what was the experience like for you?
It was remarkable. It was a great build up to it, and it lived up to the hype. We were just so fortunate to have perfect weather, the stars aligned, so to speak.
Just something to plan.
Yes, exactly. And to follow it with the glasses on, and then to have that cue to remove the glasses on at the same time to see that corona. It was just an amazing experience.
Thank you. I'm here with Madeline. She's 9, almost 10. Madeline, what was this experience of watching this total eclipse like to you?
It was crazy. I mean, I got the dress, and I thought it would just kind of look like what's on the dress. And then I see it, and it looks so cool. Like, it just looked amazing.
Are you looking forward to the next one in 55 years from now?
Oh, definitely, yeah. I'm going to be 64. Yeah.
And great dress. Great
Thank
dress.
you. I am matching with my mom over there.
Okay. David Thumb, the Sky This Month. I'm here with Rick Eames, and we are the president of the New Hampshire Solar Eclipse Task Force, and yours truly, the vice president of the New Hampshire Solar Eclipse Task Force. And I think we pulled it off today, Rick.
I think we did. We won the weather lottery of a lifetime.
We did. And the eclipse happened just as we planned it.
It did.
So, you were at the eclipse in 2017 in Casper, Wyoming. I was in Kentucky. How do you think this one compared to your total eclipse experience in Casper, Wyoming?
Well, Dave, I would say the weather was perfect both times, but what I noticed was a very, very, very bright corona. And I think it may have been due to activity. I know we're at the peak of a solar activity cycle. To me, it was just super, super bright. And there was a very, very strong solar flare prominence located at about 7 o'clock that lasted through the whole corona. It actually got some magnification on it, and it was very pronounced, very big. I did not see that in Wyoming in 2017, and I think the corona was so bright, it actually washed out some of the brighter stars we would have normally seen. I saw Jupiter and Venus, but very few other celestial bodies. It was still amazing, wonderful. It reminded me how every eclipse is different. They're never the same.
And yeah, that was amazing, and I concur. Compared to the total eclipse we saw in Kentucky, in Hopkinsville, it was significantly brighter. And I agree that the sky was, in a way, washed out by the corona because it was so bright. But Jupiter and Venus were obviously right there. And just so everybody knows, the eclipse is still going on as we're having this interview together. The eclipse is happening, and we've got about how much longer?
I think about another 5 or 10 minutes till we hit, actually no, I'd probably say 15 to 20 minutes before we hit stage 4, and the moon totally clears the sun. And I'd just like to add one other point. I had been clued in that we're getting bright red, bright green, that those colors changed. I didn't see any clothing on people with that effect. However, directly across the street from us was a gas station. And the prices are in like red LEDs, and people in our party pointed out that the lights were on the same amount the whole time, but when it started to get dark and total and come out of it, the red was really, really bright. So that was an effect I noticed.
It really did stand out. Well, Rick, thanks for joining us, and you are no stranger to the sky this month. And we wish you the next eclipse. Where are you going to try to get for the next one?
It's a toss-up between Barbados, Spain, Egypt, and Australia. But I will be there, and hopefully Dave will be there with me. Thanks, Dave.
You're welcome. And the next one in the United States, May 30th, 2033, in Alaska. What a great place to go in Alaska. Dave McDonald for the sky this month.
My name is Riley Chris, and I'm really excited for the next
Very cool. And that's the end of that. I'm going to turn the light on, so watch your eyes. It seems to be brighter the second time around. Okay, ready? Guide your eyes. 3, 2, 1. Did you enjoy that? I wasn't searching for applause, but they're always welcome. But as my mother would say, don't applaud, just throw money. Questions? I'm gonna move on to Einstein stuff, and there's a big relationship between Einstein and eclipses. That's why I wanted to kind of join these two topics together, because they are intertwined. But any other thoughts, comments, questions about our great New Hampshire total solar eclipse? Yes, sir.
Dave, is there anything about any animals actually becoming blinded or partially blinded or temporarily blinded or anything by it?
Not that I'm aware of. To be honest with you, and I've always been honest with you, we didn't see any animals. You saw the birds fly by, but we were hoping a bear might show up, or one of those raccoons would show up with their eclipse glasses on or something. But we didn't even see any animals. But the birds were confused. Other questions, thoughts, comments?
The balloons that they put up, what were they trying to see?
Yeah, so the balloons, which they put up, I assume they got all 60 of them up over a period of 30 hours, one balloon every 30 minutes. So they all have what called radiosondes on them, so the balloons go up very high, and they're tracking the humidity, the temperature, and other elements. Amanda, do you know what else off the top of your head that they are?
They're tracking the waves going through the atmosphere as well. So as the air is cooling during the solar eclipse, it does produce ripples, kind of like it would in a pond if you drop something into it. So they're trying to understand a little bit about the dynamics of how that's working and why that happens as well.
Yeah. So I don't know results. I'm sure the results will be available to the public at some point in time. Jacob, that you saw, works part-time here, and so we have an in with the inside information. So I don't have that information yet, but hopefully it was successful and they found some interesting information that they didn't know before. You're welcome.
A question from our visitors on Zoom.
Yes, question.
So a question comes in, how come we can't see eclipses at night? Solar eclipses specifically.
Well, the answer, and I'm sitting down so I can get my next thing ready as I answer your question. So we can't see solar eclipses at night because by definition, a solar eclipse requires the sun. And guess what's not out at night? The sun is not out at night. So we can't see solar eclipses at night. We see lunar eclipses at night, and that's when the shadow of Earth passes between the sun and the moon, and we see the shadow of Earth on the moon. Okay, was that good? I thought that was a great answer. So as I mentioned, and I got the date, I said May 30th, 2033. It's March 30, 20. So don't get your airline tickets for May 30th. It's March 30th, 2033 will be the next US eclipse, and it will be in Alaska. So in the lower 48, which is typically what's talked about in 21 years, okay, in 2045, is the next one that will be in the lower 48, the contiguous 48 states of the United States. There's a little one that's gonna just drop down by Montana, North Dakota in 2044. It's not a big deal, but for the people up there, it'll be nice. But 2045 is the next major eclipse crossing the country. The next one in New Hampshire is May 1st, 2029. So eclipses happen often. Every year and a half, 2 years, there's a solar eclipse somewhere, but to have it come to you, that's the tough part. San Antonio, Texas has been waiting 140 years for their total solar eclipse. And I guess they got some glimpses, but it was looking rainy and showery, and so all the people who were gonna go down there, because the weather was supposed to be better, decided to come back to New Hampshire, where it wasn't supposed to be good. We had, I think, the best weather in the country, up Vermont, New Hampshire, Maine. So, yeah, get ready for the next one. Any other thoughts, questions? You can go around the world, like, I'm contemplating going to Iceland, August 8th, 2026, so that's just a little over 2 years from now. I can see another total solar eclipse, but I gotta go to Iceland, and they don't have a great road system there, and such, and you don't wanna get covered in lava. So anyway, I'd like to go, but I'm not sure I will, but it's on my radar as a possibility. Any other thoughts, comments? Huh?
Try to talk them into go.
Oh, go!
There's only 70.
Oh, it's time to go.
Should we bring bicycles?
That's not a bad idea. You probably can rent them there, but they're probably already all rented. So yes, bring your own. Yes?
I was considering doing the Iceland thing, but since Iceland is only about the size of Maine, I think you could easily have a situation where the entire island is clouded out. So I was thinking, well, maybe like a cruise that's, free to roam wherever in the path, and then they get like really detailed forecasts and go right where they need to go. Or I guess I read about something on April 8th, they had Detroit was one airport in particular, they just went up in a regular going circle, it was like $2,000, but there you're guaranteed to not miss it. So it's food for thought.
We just, in my STEM class, have been studying the Concorde. You remember the Concorde, the airplane? I think its last flight was in 2003, I think. In my opinion, sad that it stopped flying, but that was a supersonic, the only supersonic passenger jet that would fly 2,200 miles an hour. And they would stay like for 45 minutes in the path of totality, because they were able to follow the moon's shadow. The moon's shadow, it varies from eclipse to eclipse and place to place, but on average around 1,500 miles an hour is how fast that shadow is moving. So if you're in a supersonic jet, you can keep up, and a regular passenger jet, obviously you gain some more time too, and it's nice to be able to get above the clouds, for sure. Okay, Last call on eclipse. We're gonna get back to eclipses because that is a piece of Einstein's stuff here, okay? So, if I stand in your way, just indicate for me to move out of the way. So, I don't know how many Star Wars fans there might be in the audience, but I had you, yes, I see that hand. Yes. So you see what I have up here for you? May the 4th be with you. That's tomorrow. Today's the 3rd. But there wasn't anything about the 3rd being with you, so I did May the 4th be with you. Okay, so a few things here. This is a quote, I'm not gonna read the whole thing, but Einstein, in one of his speeches, this follows from the special theory of relativity that math and energy are both different manifestations of the same thing, and we get E equals mc squared, probably the most famous equation in the world. And I would dare say he was, for this time period of his life, the most famous scientist in the world, and that it's reported that several people, when he moved to the United States and he taught at Princeton in New Jersey, would write to him from Europe and say, Einstein, USA, and they got to him. So, this month, May, the 105th anniversary of his general theory of relativity. Isn't that exciting? I meant to have a reason to have cake, but I didn't think of it in time. So yeah, it's 105th anniversary of the confirmation, I should say, not the development of, but the confirmation of Einstein's theory of general relativity. So that goes from May 1919 to now May 2024, 105 years. And that picture in particular will be significant in a bit. There it is. There's the family album photo taken in New Hampshire. Einstein owned property. He owned a cottage in New Hampshire. He loved coming to New Hampshire, and we would venture up to Lancaster and stay overnight places. He really liked New Hampshire a lot, and like I said, owned property. This picture was taken in, what's the sea, is it Chester? It's by the Connecticut River? It's not Chichester.
Charlestown?
It's not Charlestown. No. I think it's a CH word. Anyway, this was taken near the Connecticut River in New Hampshire. Einstein, obviously. His sister had the same hair genes. And this is Einstein's accountant, who was my acquaintance Marty's uncle. Who knew? And then this is his daughter, and Einstein seems to be fond of her. So again, this is a family photograph that nobody else has. So enjoy. You're welcome. Thank Marty. Thank you, Marty. So, quiz, ready? You thought it was the weekend. You thought school was over. No. What do you think? We'll take a poll here. Okay, A, B, C, or B? C. B. Oh, answers are all over the place. How many think A? How many think B? How many think C? How many think D? Kind of fairly even, a little weak on the D, but that's okay because that's not the answer. It's an urban legend that he wasn't good in math. Urban legend. When he was in the 5th grade, I don't know if you remember Euclid and Cartesian coordinates, okay, and such. Well, Euclid had his five, I think there were five postulates. And one of Euclid's postulates is, parallel lines will never cross, they'll never meet. In the 5th grade, Einstein's questioning that. Turns out later, he was right. Parallel lines do cross if you keep going long enough. So the answer is the arts. Okay, he was weak in the arts, theater, and such like that. So how about this? What do you think? How many times did Einstein marry? C. How many think A? All right, how many think B? How many think C? How many think D? All right, the majority is correct, twice. He married twice. He had 3 children with his first marriage. Actually, the first child was born just before they were married. And then he had Edward and Hans Albert. And one of the things about Einstein, very smart, intellectual, his wife was as well. Mileva was her name. And she was very much his intellectual equal. And it was nice because he could bounce his ideas off of her, and she had a clue of what he was talking about. But unfortunately, Einstein got very entrenched and very rooted in his work, in his theories, and lost contact, what am I trying to say, attention to his sons, and the daughter went to an institution. But the 2 sons that were living at home and his wife, he just kind of, got buried in his work, and so she divorced him. And then he remarried later, did not have any children with his second wife. What do you think about this? No, all of the above is not an option. How many think A? He was offered a Stradivarius violin. I see 1 hand. How many think the presidency of Israel? I see 1, 2 hands. How many think a high school diploma in middle school? I see 2 hands, 2 wishful middle school students right there. A teaching position at Harvard. That seems to be the majority. Most of you missed it. He was offered to be the president of Israel.
What?
Yeah, so he would have been the 2nd president of Israel after Ben Gurion. But he turned it down. It was his. If he said yes, he would have been the 2nd president of Israel, which just recently became a country in 1948. It's a very young country, 1948. And he was offered it, yes or no, and he said no, because he realized and knows, because particularly stuff going on with Germany and the Nazis and such, when you're president, when you're a head, the chancellor, whatever, of a country, the prime minister, one thing that you are likely to deal with are your neighbors. And that may involve war. And Einstein was a pacifist. And Einstein didn't want anything to do with potential dealings with war. So he said, no, thank you. But kind of cool, huh? All right. This is the last, no, 2 more. This one and 1 more. What do you get the Nobel Prize for? So photoelectric effect, how many? A? 1, 2, 3. B, special theory of relativity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, almost 20. Discovery of black holes. Couple there, equals mc squared. Okay, that's usually one of the more popular answers. It was the photoelectric effect. Okay, he got the Nobel Prize for the photoelectric effect. More about that shortly. How about this one? He became Dr. Albert Einstein He earned his doctorate degree. What did he get that for? What was his research? What was his doctoral dissertation about? A, how many A's? Predicting gravity waves. Okay, got 3. Special theory of relativity. 1, 2, 3, 4, 5, 6. Oh, more hands are popping up over here. No takers over there. Molecular theory. Okay, sounds kind of boring. E equals mc squared on this one. Right. It was C, molecular theory. See, back then, in the early 1900s, not everybody believed in molecules. I mean, we take it for granted, we talk about them all the time, we draw configurations and such. But back then, everybody wasn't convinced about molecules. But that's what he got his doctorate for. So, pardon me?
D and D.
D and D?
Yeah, they're the same. Close.
B and D?
Yeah.
No. In 1905, at an age of 26, Einstein had his greatest hits, to be only surpassed by Newton, who had his greatest hits, so to speak, at 23. So 26 years old, his miracle year. So let's look at these things for a little bit. So number 1 is to realize he was not person of the year, he was chosen to be person of the century. And then in 2005 was declared the world year, right? Every year is a year of something. 2005, 100th anniversary, the world year of physics in his honor. But the photoelectric effect, we experience these days all the time. Who has a solar powered anything? Maybe your house, your electricity, your watch, your computer, your calculator. Incoming photons hit metal, displace electrons, which create the charge of electricity. And Einstein found that out. He showed that light quanta, as he called the particles, photons, could help to explain phenomena being studied by experimental physicists, and this work is what won him the Nobel Prize. And we should be very thankful for that, because we have a lot of solar-powered stuff. Thank you, Mr. Einstein. Hit number 2. Remember, back then, molecules were not universally accepted. So we have what's called Brownian motion. We have an isolated drop of water, and with some tiny dust particles in it, and isolating vibrations, isolating air currents with a microscope. Those little dust particles in this drop of water are dancing around. They're doing this jig here, moving, bouncing all around. Why? There's no vibrations, there's no air currents. What is causing these little dust particles to move all around? And Einstein theorized, and later was proven to be correct, the molecules are in motion. The molecules in the water are pushing the dust around. And by George, that got him his doctorate degree. Called Brownian motion. It was an unsolved mystery, and that was the area that Einstein would get his PhD in. Hit number 3. The hits keep on coming. In June 1905, the theory of special relativity is born in Einstein's mind, because everybody thought one thing that's constant in the universe is time, right? You have your watch, you have your chronometer, and time is the same for everybody. And just like when he was way younger, was questioning Euclid's postulates, he's questioning, I don't think so. I think time is dependent. Time is relative. Depends on your frame of reference, where you are and where what you are timing is located. So he says that not all identical clocks run at the same speed. Space and time are connected. The speed of light, however, that's what's constant in the universe. It's not time, it's the speed of light that's the constant. And he showed that to be true. That's a famous clock tower in Bern, Switzerland. Whenever you hear a talk or read something about Einstein and time, typically that photo shows up. I got to go there actually and see that a while ago. We have twins. We don't have twins, no. Let's just say Amos and Andy, two names I might be able to remember. Amos and Andy are 20 years old. We have this special rocket ship that can go 95% the speed of light. Amos and Andy are 20 years old. They flip a coin. Amos, you're going on the rocket. Andy, I'm going to stay here behind. It's going to be a 20-year trip. You're going to be gone for 20 years. Thank you. So, Amos gets in the rocket ship, blasts off, gets up to 95% the speed of light. Andy goes about his life, finds a nice lady, gets married, has some kids. He's watching the calendar. Oh my goodness, it's time for Amos to come back. So he and his family run to the beach. How old is Andy? 40. He was 20 years later, he's 40. He and his family are at the beach waiting for his brother Amos to land. And Amos lands, and Amos gets out of the rocket. And Andy's like, you don't look so much like me anymore. You look like 26, which would be the true case. Amos was only 26 years old. He was flying really fast towards the speed of light. And Andy was home, normal aging process, was 40. I'm not going to belabor this graph, but this is, I teach my STEM students how to figure that equation out from the triangle, right triangle geometry. But this is the equation, and you can see the graph how you get closer and closer to the speed of light, 1.0 being the speed of light. As you get closer to the speed of light, the factor changes more and more. So time slows down more and more the faster you go. And he showed that to be true. Hit number 4. Yes, finally, E equals mc squared. All right, September 1905. Uh-oh. You recognize these dates? August 6, 1945, August 9, 1945. Hiroshima and Nagasaki. Einstein says, the human spirit must overcome technology. He said, the release of, this is after Hiroshima and Nagasaki, he said, the release of atom power has changed everything except our way of thinking. The solution to this problem lies in the heart of mankind. If only I had known, I should have become a watchmaker. Einstein had nothing to do with the Manhattan Project. He wasn't allowed. He was German. He had nothing to do with the building of the bomb. He came up with that, and then Oppenheimer and company did the rest of the dirty work on that. So, some things he said. He said, imagination is more important than knowledge. He said, I want to know God's thoughts. The rest are details. Science is a wonderful thing if one doesn't have to make a living at it. I never think of the future. It comes soon enough. Beyond 1905, and this is where we're getting hot here, massive objects warp the fabric of space and time. So, enter his theory of general relativity, this concept of Newton thought, and his equations worked pretty well for a long time, but now we're pretty much in the quantum world. But in any case, Newton kind of had the idea that everything possessed gravity. There are things that would be attracted to this water bottle because the water bottle has some innate gravity of itself to attract things. The bigger the thing, like Earth, the moon, the bigger the thing, the more gravity it possesses, the greater the attraction. And Einstein's like, I don't think that's how it works. Einstein developed the idea that space and time is like a fabric. Now, it's 4 dimensions, which is hard to picture. It's hard to picture 3 when you have a 2-dimension screen. But the idea being that you have this fabric, if you could picture a spandex sheet. And I take the spandex sheet, I put it over a 5-gallon bucket, secure it with some bungee cords, and then I get a bunch of weights. Ping pong ball, candlepin bowling ball, softball, bouncy ball, a metal weight that you might use deep sea fishing. And you put these various things, and depending upon the mass of the item, not so much its size, will determine how much of a contour that spandex sheet is going to take. The more massive, the greater the indentation. And he saw space and time, those 4 dimensions, that way. That massive objects warp that. And people were like, what do you have against Newton? Well, he said, listen. He said, something's going to happen. He said, in 1913, he wrote a letter to astronomer G.E. Hale to look for the bending of starlight during a solar eclipse. This is a photograph. I happen to have this paper at home in my library. No, I don't. I wish, right? But this is a photo, a representation of the actual letter. And it's in German, strangely enough, and I don't read or speak German. But the diagram I can see. Here's the sun. And the star is here. Okay, on the line is where the Earth is like over here on the left. The star is here on that line. Notice it bends around the sun, and this is what he's claiming, that the sun is going to bend starlight. So that star is going to appear to be up here on that dashed, dotted line. And astronomers are like, yeah, right. But they knew he was pretty smart, and he came up with a lot of good stuff, so maybe there's a chance. So the astronomers went out to various places around the world where there was going to be an eclipse. And they had very accurate, I mean, even if you go back to Tycho Brahe, they were very accurate drawings, maps, locations of where the stars are. So people knew, okay, the eclipse is going to happen. This is where the sun is going to be in the sky when it's eclipsed. These are the stars that legit are around the sun. This is exactly where they are. And Einstein's saying those 2, 3, 4 stars that we know where they are going to appear to be somewhere else, a little off. So everybody can't wait and hold their breath. Well, on May 29th, Einstein was your basic scientist. On May 30th, he was world famous. And it's the eclipse that made Einstein famous. Because what he showed happened exactly the way he said. The star that is actually here would be seen to be here at 0.84 seconds of arc off. Now, I don't have the after one, but he revised this. He thought he was off by a factor of 2. So 1.68 seconds of arc is what he finally decided upon was the right amount. And that was, in fact, the correct amount. Eclipse, solar eclipse. And all of a sudden, Einstein is famous. So that's a lot of stuff. Questions? Yeah.
So regarding relativity and how it treats time as basically like a fourth spatial dimension that we simply can't perceive, I'd like to know your viewpoint on whether that necessarily means that what's known as a block universe model of reality is in fact correct. It's basically all, entire future is determined. It's just a spatial dimension that we can't perceive. And obviously there's no free will. It's basically a deterministic universe. And since time is just the spatial dimension. I know there's some physicists who think that's not necessarily the case, but many do. So I just wanted to, know if you think that relativity necessarily implies that we do live in a block universe, basically the universe is a four-dimensional statue, and the sensation of the flow of time is just this illusion that we have.
I'm not a physicist. I studied physics, I taught physics, but I would not classify myself as a physicist. I love astronomy, I study astronomy, I teach astronomy. I would not consider myself an astrophysicist, but I do not myself, and what I know, which is a small piece of that huge puzzle that you're talking about, I don't subscribe to that. I do not believe that things are foreordained. And I have a presentation that maybe will show up again called Unveiling the Mysteries of the Zodiac, which relates constellations and the position of planets and stars and the sun and the moon in various places. Do those determine characteristics of people and their future? No, absolutely not. And if you give me an hour of your time, I can prove it to you. That astrology, fun to look at, kind of interesting, but there's no fact to it. It is what we call pseudoscience, which is false science. So I don't have a detailed answer for your question, but my belief on the little that I know is I do not believe in a deterministic universe. Good question. I'm going to wrap this part up. And so one of the things that we discovered that has a lot of mass to it are black holes. And black holes are everywhere at the center of our galaxy. So you see the red X. The red X is the center of our galaxy. And what you see are stars, the real stars, near the center of our galaxy. They're orbiting something, but we can't see it. But we know enough about the stars, their motion, their period. We can calculate the mass of what's at that red X. And it comes out to be 3 or 4 million times the mass of our sun. And the mass of our sun is like 10 to the 30th kilograms. That's a lot of kilograms. Yes?
In the video, what's up with the one that comes in, comes to red X and then bounces away?
Help me find it. Where am I going with my finger?
The one right now.
It's a different angle of orbit.
It's a different plane. Oh, okay.
Yeah, because again, you're right, yeah, we're not,
Like that, well, the rest of
it's
them
not
are
flat.
like
The
that.
real thing
Okay,
is
that makes sense.
3 dimensional. Good, will it make dollars?
That's all.
Okay. All right, so anyway, Yeah. Black holes have an effect. They are like real, they do stuff. This is X-ray jets. This is M87, 55 million light years away. I'm going to show you in the Planetarium Theater in 15 minutes or so. We're going to have a Planetarium Theater show. And I'm going to show you where to find that, because that's findable in the night sky tonight. We can find M87, 55 million light years away. And what's important about that? Well, we trained the Event Horizon Telescope. Now it's named as one telescope, but it's really 6 telescopes that are around, radio telescopes at those locations around the world. And after a period of about 2 years or so, Katie Bowman became famous. And there's Katie, when after 2 years, a team of about 200 scientists, computer scientists, astrophysicists working with this Event Horizon Telescope project, all of a sudden she's at work, she's having a snack, she's having some Cheez-Its, and glances at a laptop and bing! There's the black hole at the center of M87. And some people wrongly think she's trying to get credit for it when it was an accident. It showed up on her computer, somebody was there with their cell phone and took a picture, and she's like, oh my goodness, look at what's on my screen. The first ever photo of a black hole. 6 billion times the mass of our sun. And that's why we look there first before looking at our meager 3-4 million times the mass of the sun black hole at the center. But since we have imaged our own black hole, which is kind of comforting to know. So these things exist, and it's crazy. And gravity waves was another thing that Einstein predicted, and it was just, September 2015 at LIGO, which is in Washington State and Louisiana. It's interferometry, so they're about 1,500 miles apart. Detected gravity waves that Einstein predicted. He died in 1955, and so now, 60 years later, after he's dead, another one of his predictions is found to be true. Son of a gun. So, Hannaford, Washington, Livingston, Louisiana. Virgo is online, it's in Italy, and it's kind of become a good partner with us. And so I'll just quickly mention this. So very, 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 very sensitive instrumentation to detect motions that are coming through space. How do you know it's not a truck going by on Interstate 93? Well, these two things are 1,500 miles apart. A truck going by in Washington will register there in Washington, but it's not going to show up in Louisiana, right? An explosion that happens in Louisiana is going to be seen on the Louisiana screen, but nobody in Washington is going to know about it. But if some dramatic event happened in the universe and a black hole and a neutron star collided and sent out ripples throughout the universe, they're going to arrive pretty close to the same time in Washington and Louisiana. So this is the graph. The top one, I believe, is the Washington, Hannaford, and this one is Livingston, Louisiana. Superimpose them on top of each other, and you can see they're pretty doggone close to being the same wave, offset by just a tad that makes up for 1,500 miles traveling at the speed of light, and confirmed. we found gravity waves. And since then, they have been finding, it's not like every day there's one that shows up. But the latest one, this information, hot off the presses, like just a month ago, April 5th, they released the data and the fact that we found last May, right, a year ago, May 2023, a collision between a neutron star and another compact object, which could have been either a large neutron star or a small black hole. Einstein, still at work today. There's the Event Horizon Telescopes, picture of M87, happy anniversary, general theory of relativity, and isn't happy relative anyway? Thank you. Questions? Yeah.
The charts with the graphs were from the Event Horizon Telescopes?
Yes. No. Sorry, I spoke too soon. The Event Horizon Telescopes imaged the black hole.
Okay.
The graphs are from the two sites at Hannaford, Washington, and in Louisiana.
And which instruments were they using to measure those?
Well, you're going to be sorry you asked. I was going to talk about that, but this is it here. So in both places, they're identical. And in here, this is 4 kilometers long. And you're sending a laser beam light this way, 4 kilometers down, mirror, comes back, 8-kilometer round trip, 90 degrees, exactly 90 degrees, going off this way, coming back, and those 2 light beams should go off and come back and meet again at exactly the same time. If they're off, something happened to skew this one or this one away from each other. And that's how they measure it. In brief, in a minute, which, could be an hour, but that's the Reader's Digest version. Yes?
I'm sure this is a topic for another time, but what does quantum theory refer to, and how does that?
That's a great topic for another time.
But I mean,
It studies the very small. Like, we live in a universe where we have large ordinary things traveling at ordinary speeds, kind of a Newtonian, we might call, universe. The quantum world, which we know much more about now, thanks to Heisenberg and some other people, Henri Pauli and such, but quantum physics, the quantum world, quantum mechanics deals with the very, very, very small. Smaller than atoms. Not smaller than Eve's, but smaller than atoms. Yes?
How old was Einstein when he died?
He was born in 1878. So it's 22 and 55, 77. He died in 55. He was born in 1878. So 77 years old. He was born on March 14th.
No.
Yeah. Pi Day. What a great day for a scientist to be born. Yeah.
That first measured gravity wave, like that time offset suggests that it could measure the direction it came from. Is it known what caused that?
Two big things. And when big things, we're talking about neutron stars and black holes. And that little piece there, looking at the sky, that little piece over on the left is the high probability of where it came from.
So we know where it came from, but not exactly which.
Not exactly. I mean, these things are billions of light years away. I think we're doing pretty good. That looking in the sky, that's again, the higher probability is in the magenta. The more specific is in the yellow in the middle, but that's a lower probability. It's pretty much guaranteed to be somewhere in the magenta. They're thinking it could be in the yellow in the middle, but the probability of that being true is smaller. Well, thank you for your great attention and your great questions and your thoughts. We're going to take like a 12-minute break, and we'll have about a half-hour, 35-minute planetarium show. We'll be done just a little after 9 o'clock in the Planetarium Theater. So you got about 12 minutes, get a drink of water, use the restroom,